Hello Gurus, welcome back. It's me again. Today we are going to explore the second part of pentesters, classic shellcode injection using Nim. Before going forward, I would like to thank all those who subscribe the channel. It's really motivating me to create more videos. And if you didn't subscribe and you like the content, please do subscribe and share the content with someone who has the same interest. Last week I got a personal message from someone and asking me why I'm just creating same kind of stuffs with different languages. My answer to that is I believe the more debuggers and compilers you have, the more powerful you are when you are in computer science. Oh, I don't know how to explain the feeling of that. But the more you learn new languages and the compilers and debuggers or interpreters you have, the more powerful you have to create the new tools. That's it. So yeah, just coming back to this point, we are going to explore this one. So what I did actually, I was explaining on the first video that I just started learning Nim, and it was pretty a difficult curve for me to start learn it because first of all the main thing was the syntax. It's a kind of Python kind of syntax, and I do like Python and I do code in Python, but the syntax wise, I'm not that much not kind of familiarity, but not comfortable with the spacing and indentation stuff. So it was pretty difficult for me. And the other thing was that, as I said in the first video, the number of keywords that Nim has compared to Go, it's huge. And but the main attracting part was that that attracted me was the output that it generates is very low KB files. Like compared to the Go output, Go is mainly even if you create downloading some external binary in Go and compare your binary for Windows, it makes at least 1 MB or 2 MB files. But here it's just KB files, and there are ways to reduce your output size when you're compiling. So I'll share all those stuff here again. I already shared that in my first video how to compile and reduce the file size, but there's something else I can show today. So just going back to our code, let me take you to the code. And someone was saying they were not able to see that in their mobile phone, so I just zoomed in. I hope this will be helping them to see it in their mobile. But usually I do record it in my laptop. So I hope, and it's in SD quality, so I hope it can be readable. But if in case this is a size I'm just zoomed in now, so you can try and let me know. So what I did for, as I said, I was learning Nim, and I'm just sharing my experience with you now. After learning, I did that basic socket programming and just did a reversal that I shared on the first part. And the next thing I try to do is I just try to convert the code that I did in C# to Nim. And do you remember this one? I hope you remember this one. If you haven't seen the C# of Pentesters part, just go and check it because I have explained all the APIs and how those stuffs works in thread injections and the classic P injection. So you can just refer that. Today we are not going to make a big video and we are just cut shorting it, reducing the explanation of the APIs in fact. But instead we are going to I'm going to explain you how it can be done in Nim. So here is the shell code, the classic shellcode injection C#. Here we externally referred mm, DLL files. I mean this API after referring the DLLs here using the DLL import keyword, and this was in runtime interop services namespace. So here for the same stuff, if you want to do in Nim, uh, the only thing you have to do is just import this binary, not binary, this module. WinNim is a main module, and inside that Lean has all these Windows APIs that I have used here in this program. So if you want to uh, If you want to install that this module, only thing you have to do is just use a nimble. Nimble Nimble is actually the installation binary module. I mean, it helps you to install the extra modules that you can include in your Nim program. It's just like Go Get in Go programming, if you are familiar with that. So the main thing, but the main challenge for me was when after I installed Nim, Nimble was removed by my Defender by saying that it was kind of Trojan. Then I checked checked some MD5 and SHA, some they have provided their site. It was matching, nothing was wrong. Then when I searched one of the forums in Nim, they were saying it was because of some malicious history it had, or I don't know why. There was no clear answer on that why it is removing. But I checked my network activity after and using Nim. I couldn't find anything wrong in that, so I just whitelisted my and the Nim folder. Now it's fine for me. Different is not doing any disturbance. So just please do install the WinIM library before using this one. So yeah, just come to the code. This is the main thing you have to do. You have to import the WinIM and inside the WinIM module, we are just using the lean area of that instead of taking the entire WinIM module. We are just taking the part of that just to make it more compatible. So this keyword is kind of predefined set, and yeah, it says that it just checks. You can completely avoid this if you want, but it checks whether this Nim code is going to be compiled on Windows or not. And I'm for you. I don't know. Did I say this one? I'm just referring this book for learning Nim, and this is a pretty good book that explains pretty well if you're starting with Nim. And I just took this explanation from the book. So it just checks whether its code is going to compile in Windows or not. And if you see on the C# code, here we are declaring a byte array. Um, and this is the way of declaring byte array in Nim. This is insane for me, this syntax. But I'm just getting familiar with this one. It's nothing but we are just saying it's an array, and here you have to, instead of this two, we have to specify the actual binary file size. Uh, I mean actual binary byte array size here. We are just saying it's a byte array. So again inside the square bracket we have to again specify the byte keyword. I don't know why that kind of syntax they are using. Yeah, just maybe it's making more clarity or something. I don't know. So the next thing is next challenge I was facing was just how to convert that code to the Win API here. Uh, Win virtual alloc. You know what exactly it's doing, right? We are just making a section on our current exe. So we are saying that the section should be execute and rewrite, so that we can just execute our shellcode inside that. The main challenge again here was typecasting stuff. Here you know how this works, right? Yeah, the first part we have given the in pointer 0 value here. It was the first parameter of this function. Windows API was in fact the LP address. What it says according to that their definition of this API, if this parameter is null, the system determines where to allocate the region. So we are enforcing the system to allocate the region. We are not saying any specific address. So here instead of the null or the pointer 0 in C#, we are just passing a nil. Nil is equivalent to null. I hope in this, yeah, is equivalent to null in Nim. So we are just enforcing uh, the OS, the system, to determine where to allocate the region. So next is the shellcode length, and again this is another thing. I will show you how the errors it is going to make in this one. You have to convert this to size t, because this alloc, if you check here, you just pointing it after installing that Nim compiler. The Visual Studio Code will show you how to actually the exact syntax of this virtual alloc function. The second, you can see the second parameter is DW size, and the type of that is size underscore t. So you have to cast that, you have to typecast that normal integer value to the size t value. Then these are the parameters, the constant values that is defined inside the WinName, so you can directly pass that. And the next one is what we did on the C sharp, marshal.copy. Actually, we are just copying our actual exact shell code into that memory that we just allocated. So we are doing the same thing here. So instead of the marshal.copy in C sharp, here we are using copy mem function that will help us to copy our shell code to this one. Again, the syntax will be pretty pretty tricky for me. I just did an online search, and yeah, there's one more thing I forgot to mention. There's a collection of Nim offensive Nim collection. You can refer that if you want, but that may not be some exact stuff that I'm sharing here, uh, because most of the stuff's defined there is not that much straightforward. I didn't feel that much straightforward because the way I did on C sharp was like, as an example, I can just going forward, I can show you how different it is. So here, the main thing I try to do is I just converted my C sharp code to name. You can refer that offensive name. That's really a good collection. That will give you more insight into this WinName module and how we can make use of other APIs. So after copying this one, copy our shellcode into memory, the next thing we have to do is, as we did on the last part of C sharp, we have to execute this shellcode, run this shellcode into the memory uh, that we created using the virtual alloc. So so for that reason, we are just using the create thread. So I will show you. Just showed you how to insert. I mean, the real reason here, if you come here, the parameters it accepts normally the in pointer 0, then normal 0 here. Like second parameter here in C sharp, it is something the length of the actual stack size. So I'm going to suppose if I'm going to pass uh, in C sharp, I pass second parameter 0 as a normal integer. Suppose if I'm going to do the same stuff here, and if I compile it, I okay, that parameter doesn't make any. Okay, that parameter doesn't make any difference here. It's good. When I was doing the last time, I mean before when I was working with this, it was complaining me with some errors. Okay, let's not complaining now. Okay, let me do change something. What I'm trying to show you is here. Okay, let us go to the third one. The address, yeah, address should be okay. This one may be helpful. So we already have the address from here. Uh, Shellcode address, shellcode pointer that actually points to our Nim library. Uh, yeah, here it's just showing there. And if you build it, here it exactly shows what the mismatch is, like where the mismatch. You can find out where the mismatch is. Here it is expecting these parameters, and if you check here, the first parameter is a kind of LP thread attributes, and the attribute type is LP security attributes. That's where I converted the first value. Even though it's a null pointer, we have to cast that to this attribute. I tried to show you the same thing using the size t, but it didn't make any complaint, so I just kept it like that. Even the third parameter is the third one is LP start, yeah, the LP thread start routine. So instead of, I mean, you can't directly give this pointer. You have to cast this pointer to LP thread start routine. So that's a main challenge I was facing when I was using this one. So I'm just this is a way to cast this your normal pointer to the pointer that this API needs. I'm just taking I'm just keeping the exact size, exact casting size, just to keep it just understandable. Because if I try to keep if I try to keep this one without converting, this is even confusing for me in the future. So I'm just converting everything to based upon what exactly this API is defined inside the minim. I'm just this is a type of the parameter and the name of the parameter. You just convert everything based upon the type it's expecting, so it's easy. Just use the cast, and inside the square bracket you just give what type is expects. Here after that LP thread start routine, I have given LP void for the last zeros and a D word and the LP word. I just converted that, even though all those are zeros. We just use in C sharp. It was some pointers, nil pointers, and some are zeros. Some accepted normal integers, some accepted only the pointer to pointer that integer pointer zeros. So here, that's the easy part. Just convert everything as just like what that API is expecting. So there won't be any confusion. Instead of giving some part as normal integers and some as converted values, just give everything to converted values and cast everything as the API expects. And the last part, yeah, single object, wait for single object API call. And again, this API was expecting, actually, if you point here, you can see it's expecting a handle, and the third handle type should be converted to casted to handle type, and this should be doer type. Just do that. There's no isn't nothing to worry about, because it's a kind of safe implementation, safe use kind of usage. You don't need to worry, or you don't need to get confused. If you do it like a half as I said, maybe some point it accepts some kind of value without converting. Maybe as I was doing this one, it was accepting without the size t, the shellcode length. But I'm just going forward, I'm just using all this cast converter type instead of just mixing it up. So that's it. It's just this much piece of code will help you to do that classic shellcode injection. So the only next thing we need is we should get our shellcode. So let me start my Kali Linux and get the shellcode. So when it's starting, and the other thing that I already told you, it attracted me that the size of the binary is making, and the options to reduce the binary size. It was amazing. But I did face some other issues, because I didn't feel like the socket part of this one was that much stable. Because I faced a lot of issues when actually the first thing I tried was the same thing that I did last time, the PowerShell without PowerShell.exe. And when I tried with the Nim lang, I was getting the shell, but it was not an interactive shell. The shell, it was after getting the initial connection, it was the socket was just disconnecting. Might be because of the issues that implementation inside the minim and CLR libraries. I don't know. I will share that on the next video, the failed attempt of that, so you can learn better. So let me, yeah, just start this one just for sharing our service. Okay, same massive venom. This is B L host. It's 72 same. Yeah, nothing changed till now. So just checking this shell code. Uh, Notice in total number of bytes. It's 791. It's 791. Copy selection. Sudo shell text. Is just because the copy paste is not working perfectly, and I'm using that, not the latest Linux, and the latest one they were saying it will work. I didn't update that. I didn't upgrade to that till now. So let me, yeah, nothing changed on the IP side, so it will be the same. I'm just starting it here. So let us go to our machine here, 192. Just ensure it's working. Shell.txt. We are copying that shell code and taking it here and just pasting here. Removing this one, paste it here. Oh, what is that? 790. I forgot that. Oh my god, this length of the shell code was 791. So you should give that here. I don't know whether there is any other way like C sharp. C sharp doesn't need any kind of initialization number here, because I will show you in C sharp that was a better part. Here you don't need to specify the length of the byte, right? Automatically assigns that. But unfortunately here I don't know any other alternative here. All the stuff I searched on the online, it was with this array length. So might be some other way. The more you learn, the more ways you can find out. Yeah, maybe in future I can do it better. I can share that. So we just updated our shellcode. Shellcode is ready, and we allocated them enough memory buffer for us. Using the virtual alloc, and we copied that our shellcode into this virtual allocated memory, and we are running that, and we are just waiting for a single object to close it. So yeah, now we are going to compile this. For compiling this one, actually I got this compilation option from the offensive Nim that I say the collection GitHub. He clearly mentions how to compile the cross compile that stuff. Maybe in Windows you don't need to use this one, but if you are doing it from somewhere, you may need to do like this. So I'm going to, even if I think without this one it will compile. Let me try. Uh, yeah, it will. Actually, it's a cross compilation option. Like if you are doing it from some other operating system, or some, if you want to specifically aim something. But my expectation is this will create a 32, not 64-bit, because our shellcode is 64-bit. Let me check the file size. And we may need to recompile it if it's not going to work. It's 175 KB. It's 175 KB. You know, there's another file I created. It's a Golang reversal, and if you check the file size, it's 2.66 MB. Compared to that, is pretty low, but it's not that much lower like that .NET binaries. .NET binaries normally it comes with 5 KB, 7 KB, like that. But even 175 KB for a shellcode injection is pretty good, in fact. And even you can reduce the size using some other switches. I will show you that. Let me, but I didn't check with this option. Actually, I was checking all this with this option. So might be the same stuff. So let me copy this to our victim machine. So we can test this. Copy p injections into drive share. Let's copy and let's go back to our victim shell and just ensure that our this one is running. I think, yeah, it is running. Yeah, if okay, copy the drive p injection here. This Z drive is the shared drive I am just sharing with my host machine. Yeah, it's here. Hopefully it will work. If it's not going to work, we may need to recompile it. It's here. Oh yeah, it's working fine. It's a good news. Um, yeah, we have a working session and just go to shell. We have that interpreter we use for this HTTP reverse HTTP, and we did classic P injection using the Nim. It's very easy. It's very less number of lines. See, this did the trick. Created call the APIs, copy the memory, and created the thread to run it, and just call the wait for single object. That's it. It's all defined in WinIM library. So we should thank that guy who created this winning library for us. It just made our task very easy. Yep. I will show you some the next stuff I can share you that. Yeah, normally this is stuff if you want to cross compile and if you are aiming for from doing, I mean explicitly you want to specify 64-bit or something, and it because I'm on a 64-bit machine, I think it did compile it to 64-bit, so it didn't make any difference here. But if you want to reduce the size, you can do this one. Hyphen D danger, hyphen D strip, and hyphen optimize the size option. If you are adding this one, I will show you this dramatic change in size. That was shocking, in fact. This is a 175 KB file. So if you are going to, where is my console? So I already used that command. See here, I'm going to use a D danger and D strip. Before doing this one, you have to ensure that your exe is working, and you can instead of danger, you can do the release mode. Then also it will reduce the size. So just ensure that every point is working fine. So this command will reduce the entire size of the binary from 175. Yeah, I think it's 175, right? It's 175 KB now. Just see the magic. It's so it's created the same file. Where is it? See, it's 68 KB. It's reduced more than 100, and it's 175 minus 60 is how much it is. Just calculate that. It's reduced a lot, like from 175 to 68 KB. Even there is one more switch. If you give the pass C to this option, pass L. Actually, I didn't go deeper into what are these options. I will learn more about this option. I'll explain later. But when I'm searching, it's 68. You can reduce a bit more bytes if you are giving that. Yeah, here I'm just giving the pass C and pass L option and just see how much. It's not that much different, but again you can reduce the size using these options from the 68 now. C65. Yeah, it's not a big change, but 3 bytes difference. 3 KB difference. Actually, it's not bytes, it's KB differences. So from the 175 KB, we cut short into 68 KB. Then after adding this pass some options, pass C and pass L options, it again reduced to 65 KB. Yeah, just this is a better part in this one that attracted me more. And there are a lot of other stuffs, and I'm just searching why Defender is complaining Nim stuffs, and I got from various resources that Nim is a new uh, language, is a favorite language of malware writers because of the features it's providing. It has some features that will help to do some on-the-fly memory stuff like keeping the entire compiler somewhere on the memory and generate some code from memory and run it from there. So a lot of complicated stuffs are there. So the malware writers will love it. Maybe we can explore that in more in future. And this is my progress in Minlang. I'm Nimlang, and I will show you more stuff while I'm learning more. And this that's it for this video. Again, yeah, the last part. And these are the APIs we use, just like. And if you didn't see the part of the same part in C Sharp, there I explained well how these APIs are working and what exactly these APIs are doing. So if you want a better clarity on that, just refer to the C Sharp one before coming here. And if you are familiar with this API, it's fine. It's very straightforward. So you can just use it. Yeah, that's all for this video. Just subscribe and stay tuned. If you like that content, subscribe and share and stay tuned. We are coming up with more videos. I'll be busy with developing my AV Buster. I'm just converting the entire structure of AV Buster. Currently, I'm working on the API side because I want to use that API, Golang API structure there, and I'm building that front end in C Sharp desktop application and backend to be Golang API because the concurrency and the threading in Golang is very stable and it's very fast. So I'm working on that. In between, when I'm getting time, I learn Nim and I make more videos. Plus, I will continue C Sharp for pentesters. Plus, more stuffs are coming. Yeah, more stuffs. So just stay tuned and subscribe and share.